So in this class we are going to discuss about potential energy. So potential energy of a body is associated with position and configuration with respect to the surrounding. So for example, a body is at rest here. So now the potential energy is 0. The same object is lifted to a certain height h. So at point B. So it is lifted to a height h. Now the potential energy is, it has some value. So potential energy of a body associated with position and configuration with respect to the surrounding. So position I explained. Now the configuration. So configuration means, so consider a spring. So now I am applying a force. So this is expanded or compressed. So the configuration is changed. So with respect to the position and configuration, so potential energy is defined. So potential energy of a body at a point P, just see this picture. So potential energy of a body at point P is defined as amount of work done by an external force. So I am lifting an object from the initial point O to the final point P. So moving an object at constant velocity from initial to final location. So this is initial O, the final P. At constant velocity. So constant velocity means here acceleration is 0. So change in velocity is acceleration. Here we are moving an object at constant velocity. So velocity is constant. So potential energy of a body at a point P is defined as the amount of work done by an external force in moving an object at constant velocity from initial point O to final point P. Then there are various types of potential energy. So various forms. So potential energy due to gravitational force is gravitational potential energy. So the energy due to the spring force or some other similar forces, it creates elastic potential energy. Then energy due to that is electrostatic force on the charges. So that is electrostatic potential energy. So electrostatic potential energy is in capacitor. Then potential energy near the surface of the earth. So potential energy near the surface of the earth, that is gravitational potential energy U. So here consider an object. So this is a mass M. So it is lifted from O to B, that is initial to final. We are applying some force. So some work is done. So it is displaced from O to B. So gravitational potential energy U at a point P is amount of work required to move an object from O to P with constant velocity. So again that constant velocity means here acceleration is 0. So at the point P, so there is a force acting downwards, that is a gravitational force. So gravitational force is equal to minus mg j cap. So why it's minus? So the force acting downwards, so negative y direction. We need to lift the object, we need to apply some force opposite to the gravitational force, that is applied force Fa is equal to plus mg j cap, because plus, that is in plus y direction. So here Fa and Fg are equal and opposite direction. Then so the gravitational potential energy at a point P, that is U is equal to integral F dot dx. So potential energy is some work is done. So work done equal to force into displacement. Here integral F dot dr. So from initial to final. So the limit is 0 to height h. So again that applied force, then the displacement, if there is any angle, that is cos theta, here the angle theta equal to 0, because the applied force is in upward direction, displacement is also upward direction. So the theta is 0. So cos 0 1, so integral Fa. So the magnitude Fa, that is equal to mg here. Then magnitude of displacement dr, that is dr. Then so just substitute. So U is equal to mg integral dr. So the integral again from 0 to h. So integral dr equal to r. So just substitute. So upper limit minus lower limit, you will get mgh. So the gravitational potential energy U is equal to mgh. So we are applying some force. So here the energy is transferred. So now the potential energy is 0. Here the potential energy is maximum. So due to the some work is done. So some, that is potential energy is stored form of energy. So if you release, it will come back. So potential energy is converted into kinetic energy. So potential energy stored means we are transferring energy in terms of external applied force. So here U is equal to mgh at the object of mass m is lifted from initial to that height h against the gravitational force.